Hi, it's Kevin Bates here. So today I want to talk a bit more about randomness, because when it comes to a proof of work or a proof of stake system, there needs to be a random mechanism proportional to the amount of work or the amount of stake that the participant is putting in order to select the next participant to mint or mine a block. Now, in proof of work, the randomness is fine because there are all these miners popping up all over the place, running different amounts of work with different nonces that they put into their different blocks in order to try and generate the next block. So you've got a lot of what in information theory is called entropy there. However, in proof of stake, I think there is a problem in that the entropy of the system is very, very low. There's no external output. It's a sealed system. And this and the fact that you can actually go back and rewrite history if you're clever enough means that there could be a real problem. And the way I'd like to illustrate this is through the use of an analogy, namely looking at a pseudo-random number generator. And the one I'm going to use is pi, because if you look at the decimal expansion of pi, you'll find that the digits in that expansion are uniformly distributed. What this means is that the digit 0 occurs about as often as 1, and that occurs about as often as 2 and 3 and 4 and so on up to 9. So no particular digit dominates, and they're not set in any kind of pattern. They seem to come along in a random fashion. However, if you and I both go and look up what the 100th digit of pi is, then we're going to get the same answer. So it's pseudo-random in a way. There's actually it behaves randomly, and yet it's fully deterministic, some strange mathematical property of the universe we live in. So using that randomness, I'm going to propose a game to you, which is you pick a number between 1 and 500, I pick a number between 1 and 500, and we add the two numbers together when we reveal them to each other at the same time. And then if the digit at that point is even, then you win, and if the digit at that point is odd, then I win. And this should be a great fair game because, as I said, pi's decimal expansion is appears to be random, but if we play this again and again and again and we stake $10 on each game, in the long run I'm going to win, because it turns out that 52% of the first 1,000 digits of pi are odd and 48% of the first 1,000 digits are even. So what happened there is I went and looked at this deterministic system and got some more information about it, and therefore forced the game onto you in such a way that you were going to pick evens and I was going to pick odds, and I did that on purpose. So there's an example of when you have a pseudo-random system, there's a risk that people can go and play the system, and that's what I fear could be the case with proof of stake blockchains, that it's possible for people with large stakes to go back and look at different possible futures that come out of the consensus protocol that's coded into, for example, the Peercoin system, in order to select new branches at a later date that are more advantageous to them, that allow them to mount a double spend attack or something else. So that's a video post on randomness and entropy, and I think it's something I'm going to come back to again because I think it's quite a key point in blockchain, and I've not seen too much written about it. Anyway, hope you found that interesting, and see you soon in the next video. Bye for now.